Well, hello. This is an introduction, or for some of you, a review of qualitative research terms and practices. So the first thing is that quantitative research is a systematic approach to studying a phenomenon through quantifiable data and objective analysis. Quantifiable just means data you can turn into numbers. There's nothing specific about that data. You can actually start with qualitative data and convert it to numbers using a Likert type scale or something like that. Likert type scale. I should have said that correctly. The focus of it is explaining variables and asking specific questions, collecting measurable data, and then analyzing that statistically. And the characteristics of quantitative research is supposedly it's objective, reproducible, and it has numeric data as key components. The validity of quantitative research is what's important too. We're trying to reduce alternative explanations of the findings and insert credibility and accuracy when doing quantitative research. And there's two kinds of validity. One is internal, which is basically determining whether the changes in the dependent variables are related to the independent variables. And I'll talk more about those two terms in a moment. And then there's external validity, and that's whether or not it's generalizable to other contexts and populations. And the whole idea is to be objective in this research and maintain unbiased methods to strengthen the validity of your findings. So quantitative research designs are the way to make that happen. So it's a set of procedures for collecting, analyzing, and reporting numeric data to answer research questions and test hypotheses. So there are, as you undoubtedly know, there are experimental research designs, quasi-experimental designs, and survey and correlational designs. The experimental designs are the gold standard. They test interventions by manipulating conditions and using random assignment. And so randomly controlled designs are what's the gold standard in that. Quasi-experimental designs are what we mainly use in education, and that's measuring relationships without manipulating variables or groups. And then survey designs are just used to explore associations and relationship and trends among two or more variables and can get very complex. Data collection and analysis, it's turning observations into numbers. So the first thing is on data collection. The common methods include surveys, observations, and performance assessment, any of which can be converted to numbers and then analyzed numerically. So converting them is basically sometimes losing information compared to qualitative data. It's translating them into measurable variables. So if you ask a question that there can be multiple responses to, or if you do an observation, that could be multiple things you're looking for, you can turn those into numbers. If you do this, how many times do you do it? If you do that, how many times do you do it? So it isn't just about an overall data collection methodology, but it's about how you can convert it into some sort of numbers. And then, of course, the basis of it is statistical analysis using descriptive or inferential statistics, and we'll talk about more in just a moment on that. So the important thing about quantitative research is the indication of variables. It's a characteristic or attribute of an individual organization that can vary. And so independent variables are things that you can manipulate, like programs, characteristics of your population, of your sample. Control variables can influence anything that can influence a dependent variable. We'll talk about that more in a minute. A dependent variable is an outcome that can be influenced by changes in the independent variable. So say, for example, you have a program where you're trying to teach English learners something. That's the independent variable, is the program. The dependent variable is how you assess whether or not they acquired that information. And then there are confounding variables that sometimes we either can identify but can't measure, or do try to measure, but typically they're not directly measured in a study. And then most important thing about quantitative research is sampling, and that's deciding who your participants will be and ensuring that they have some representativeness in some population. So the term population means the group that you think the findings can be applied to. The sample is a subgroup of that group that represents the population, and you can select that sample by various strategies. the terms probability sample or non-probability sample are used for a group of types of sampling. One is random sampling, where you say put all of your population into a list, take a random number generator, and then whatever number comes up, that person goes into your sample. And that's fairly typical. It doesn't happen much in education, but it's very typical in medical research and things like that. And then a stratified sample is when you know certain characteristics that you want the population to have, you would randomly select and make sure that they've hit a certain strata. So example of that is gender identity. You might say that it should be roughly some percentage of male, female, and binary, and you want to make sure you select from the group to find those percentages that represent the population. And then non-probability samples are what we use a lot in education. Convenience samples just means it's some group you have access to, a group of students or a group of schools that you have, or of colleges or universities that you have access to. A purposive sample is saying you selected these schools or selected these colleges because they meet certain criteria for your research design. So those are the different kinds of sampling strategies. And then the biggest question that comes up about sample is what size of sample should I select? That's the number of participants that gives you confidence in the reliability and generalizability of the findings. Good example of that is in the recent presidential election. They were sampling in various states to see which of the two presidential candidates were leading. And when they reported them out, they said, oh, the sample showed a 0.5 difference or a 0.3 difference. And then in the little corner of the thing, it would say plus or minus 3, plus or minus 4. So what that told us in the sample that they selected, that there was not a big enough difference to actually say that sample predicted something. And so we went on into the election day not knowing who would come out of those important states that decided who the president would be. And so that tells us about the generalizability and reliability of the sample we take. Interestingly, on those samples that they did in states on the presidential election, where they might have had thousands of people voting, or even hundreds of thousands of people voting, the sample sizes were 2,000 to 3,000. And that's why the standard error of measurement was so large, the 3 to 5 points. Sampling error is all about that standard error of measurement, and it's whether or not the sample that you've selected represents the true population values. And then one of the things in quantitative research that we work on is ensuring rigor. And so two strategies are available for that: triangulation and validation. Triangulation is about using more than one source to enhance your reliability. So say if you're assessing student learning of English, again, back to this English learner model, there might be multiple ways you can assess that. The more ways you assess it, the more you can be confident that you've had a real change in the behavior of those students. And then validation is employing strategies that ensure the accuracy and credibility. For example, calculating a standard error of measurement so that you know what the range is when you say something has changed. Good example of that is I was in a conference in Southern California last month, and I was listening to a researcher that used statewide data to determine the impacts of alternative strategies for teaching outside of the school day, extended learning opportunities. And he was so excited when he reported at the end of his report that using these thousands of students that had these expanded learning opportunities across the state, they'd seen a statistical change in the student achievement of those students on the Smarter Balanced Summative Assessment. And he said, it's so exciting. We had statistical difference, and it was a 1-point change in scale scores on the Smarter Balanced Summative Assessment. Well, being the smart aleck I am, I raised my hand and I said, what's the standard error of measurement on the Smarter Balanced Summative Assessment English Language Arts Test? And he said, I don't know. And I said, well, I was looking at it the other day, and across a full population, it's something like 3 to 5 points, up to 9 points, and different subtests of that. And for an individual level, it's 200 points. So tell me what 1 point means to you. There was silence in the room. The bottom line is, if you don't pay attention to standard error of measurement on assessments, you can say something changed because statistically you got a significant difference, but it really means that in the population nothing much changed. And then the last thing in terms of rigor and ensuring the validation of results is replication studies. What's really important is if you want to know if something really makes a difference, it needs to be reproducible. And that comes from having detailed procedure documentation of the group, the context, the assessment strategies, and the treatment intervention that you tried. So those are things in quantitative research that can help you make it more valid. And then the limitations of quantitative research is challenges to objectivity and scope. So the biggest problem with quantitative research is context-specific findings, things that work only in the result, only in the place in which they were implemented. And this is common across education because education is a complex organization with so many variables that can change, not only among the student population, but among the teaching population, the context of the school itself, all kinds of variables that we can't control. And so context-specific findings are what we find in many education studies. And you'll learn more about that as we take a look at the book that we're using this year. And then measurement limitations, capturing complex behaviors with quantitative data. It simplifies it down so much that it might not really make a lot of sense. That if you get a number 1 or a number 2 on a certain score, is it really that different? So measurement limitations, and then also potential bias. Any assessment that we use has potential bias built into it. Good example of that is achievement tests. All achievement tests are based on a belief that student learning can be represented in a normal curve. And when you think about that concept, it is based on the concept of intelligence that also many believe is in a normal curve. Many of those things are really not objectively created, but they're reinforced by assessments that are used, and that potential bias is built into everything. And as we talk about assessment, we'll talk more about those potential bias. So that's your introduction or reintroduction to the language, the terminology of quantitative research designs. Thank you.